Hey there, we're talking about some special types of quadrilaterals or more specific types of parallelograms. We're going to be focusing in on the rhombus, the rectangle, and the square. All right, so here's some key definitions. I know you probably know what a square and rectangle are, but let's look at very specific as what they are. A rhombus is a parallelogram with four congruent sides. So we don't get into any kind of angles or anything like that. We're just focusing on the sides. And if that's the case, then we have a parallel or a rhombus. So again, it's already a parallelogram. We already know this, but now we know that this guy is going to have four congruent sides. And so this would be a picture of what a rhombus would look like. Moving on, we have ourselves a rectangle. A rectangle is a parallelogram with four right angles. And that's the only thing that it needs to have. We don't care about the sides. Obviously, opposite sides are congruent and so on. But what we know in this one is that all it has to do is have those four right angles, and we know it's a rectangle. Okay? And then finally, we have our square. Our square is going to have a combination of both the rhombus and the rectangle. So we've got four congruent sides, and we're going to have four right angles. So once we put those two things together, now we have ourselves a square. Okay, so that's very important that we're going to get all those properties for squares and is coming from our rhombuses and our rectangles. Okay, all right, so let's look at some very important theorems. We've got our properties first for rhombuses, and then we move on to rectangles. So here's the first thing: the diagonals are going to be perpendicular to each other. So when they come together, they're going to meet at a right angle. So we have four right triangles here. Um, the next thing we have there is that they're going to be angle bisectors of the opposite sides. Okay, so now not necessarily is angle 1 or angle 7 going to be congruent to each other, but we see here is that the two angles next to each other, they have to be the same measure. The two angles next to each other, they have to be the same measure, okay? So not only do we have a right angle here, okay, we're going to form perpendicular bisector, angle bisector, so that we have 2 and 1 are going to be the same measure, 5 and 6, 7, 8, 3 and 4. And what I want you to kind of notice here is that, yes, these are meant to all be in red. Well, if it's a parallelogram, that's because opposite sides or opposite angles are congruent. And since that's the case, that means 1, 2, 5, and 6 all have to be the same measure. Same thing with 3, 4, 7, and 8. They're all going to be the same measure. And what you should notice here is that we've got ourselves essentially four triangles that all have the same exact. We've got two angles that are the same for each of them. We share at least two sides for all of them. So just kind of keep that in mind as you're working through some problems, okay? All right, now for rectangles. So rectangles, we already know that they're parallelograms, so they have all the properties of the parallelograms, and the diagonals are going to be congruent to each other. So what I see here is that when I connect from A to C, that's a diagonal where you connect two vertices together, A to C, and I connect B to D. Those are the only diagonals that exist, because if we were to connect A to B or anything that's a side, those lengths are going to be congruent to each other. Oops, sorry. All right, so that's the most important property we have for our rectangle. So AC is congruent to BD. So again, like we said before, all the properties of parallelograms are going to apply to a rhombus and a rectangle. So opposite sides congruent, opposite sides congruent, opposite sides parallel, and so on. And then now, since we talked about before that a square is a rhombus and a rectangle, all the properties for parallelograms, a rhombus, and the rectangle are also going to have to be the same properties for a square. So if you were able to show, so if I tell you that something is a square, you can do all of the math knowing the properties of the rhombus, rectangle, and parallelogram, okay? Now just note that all the converses are true. So for example, if I were to give you a parallelogram and I saw that the diagonals are going to be perpendicular, I automatically know that it's going to have to be a rhombus. Kind of like how you were doing the problems with the parallelograms, where first I told you it's a parallelogram, so all this was true. And then the next section was, okay, this is what I'm giving you about this shape. Can you tell me it's a parallelogram or not? So it's kind of that same idea. If you are able to show one of the properties of the rhombus and the rectangle, then you are able to show that it is that rhombus and rectangle. Okay? All right, so here's just a nice little visual diagram for those of you who like to kind of see it out loud or out on paper like this. So this is my parallelograms here. I know that opposite sides are parallel. And so over here I have my rhombuses where they have the four congruent sides. And then over here I have my rectangles with my four congruent angles, or four right angles. And when they meet together in my Venn diagram, that's when we form the squares. So I know that the square has the right four congruent sides and the four right angles, and all these guys all have opposite sides being parallel. Okay, so that's just another way to visualize things. All right, let's do some examples. We're going to identify the parallelograms for the first two problems there. So looking at what I'm given, I want to determine what it is. Again, I already know that it's a parallelogram. So that's something that's being told to us. Okay, so for this first one here, I'm kind of taking a look. All right, I got this right angle here. Am I able to say that anything else is a right angle? Well, yes. Opposite angles are congruent. and consecutives add up to 180. So I know this is going to have to be a right angle, and this is going to be a right angle, and so is this. Well, that's giving me enough information to tell me that it's going to be a rectangle. But do we have properties of rhombus? Well, yes, because if opposite sides are the same, that means this one's going to have one tick mark, and same thing with this. So all four sides are going to be congruent to each other, so that's properties of a rhombus. So it's got the four right angles and four congruent sides, so therefore it is a square. That's kind of what we're looking for you to be able to do. All right, taking a look at the one on the right, I see I have the 130, so I automatically see I don't have properties of a rectangle because I don't have a right angle. I do see that I have myself four congruent sides, so that's going to be enough for us to tell us that we have a rhombus. Okay, so now we're down here at the bottom here. I'm telling you that it is a rhombus, so let's kind of figure out what we know about that. Well, the diagonals are going to end up being angle bisectors, so that's one thing to keep note of, and that the diagonals are perpendicular to each other. So let's kind of figure out what we can do. Well, number 2 is nice and easy. Since the diagonals are perpendicular, I know I'm forming a right angle there. Angle 3 is another one I can find nice and easily because, again, these are angle bisectors, so these two angles are equal to each other. So if this is 50, that is also going to be 50. Well, then from there, we can use the fact that we have a triangle. That's a right angle, so we're going to subtract 90 and 50 from 180 to get 40 degrees. All right, last problem here. We got JKLM as a rectangle. If JL is 4x minus 12 and MK equals x, what is the value of x and what's the length of each diagonal? Well, I can't look at this and be able to determine what this looks like, so let's draw a diagram. So I got myself JKLM, so that's the order that the vertices have to go in. Doesn't matter where they are, you can put J down here if you feel like it. Just make sure you're drawing JKLM in some way. So JL I see as a diagonal, and so is MK. Well, what do we know about diagonals for rectangles is that they are equal to each other. Okay, so what I'm going to do then is I'm going to take the 4x minus 12 and set it equal to x, and I'm going to solve. This is just algebra, so subtract the 4x and divide. I know that x is equal to 3. So now I want to find the measures of both of those diagonals. I'm going to substitute them in, and I get the value of 4. And that's about it. All right, here is that flow chart. So far you filled in everything about parallelograms. Now we're going to fill in the properties of our rectangles and rhombuses and squares. So the things we got for a rhombus was there was four congruent sides, the diagonals are perpendicular, and they are angle bisectors. And for a rectangle, we have four right angles, and diagonals are going to be congruent. And then for a square, it's everything above us, okay? So here's how we kind of use this, is a square is property of rhombus, rectangle, parallelogram, and anything with a quadrilateral. The rhombus is going to be parallelogram and quadrilateral. The rectangle is parallelogram or quadrilateral. As you see, we don't go side to side. So this is kind of that idea where every square is a rectangle, but not every rectangle is a square. So we don't work our way down. The properties only work their way up. Okay, so go ahead and hit the pause button and get these properties written down, and that's it.